All right, this will be a real quick video. We're just doing these last two problems from this practice test. Oop, what's going on with my screens? I can't, it won't let me write. Ah, there we go. So we're going to use, instead of the trapezoid rule, I said, what if we call this the right-hand rule? Or the right endpoints? Then we could definitely do this one. All right, so what does this thing look like? Well, let's get a little picture. Now, I could draw it accurately, right, where it would look something like this. Parabola. The picture doesn't matter too much, honestly, because I'm just using it to help me visualize what's going on. So we're going from 0 to 4, and we want n equaling 4, so that means it's going to be 4 rectangles. I said I'm going to use right endpoints. So I just need to find the heights of these rectangles, etc. And so I would know that the base of each one is 1. And these are the points 1, 2, 3, 4. Right. The way you could think about that for this one is pretty obvious, but if I did 4 minus 0 is my range over n, it gives me my delta x as 1. Now I could multiply each one by it, but I do like to factor out the delta x. So 1, and then we're going to have the function value at 1, plus the function value at 2, plus the function value at 3, plus the function value at 4. So if I'm using the right points here, we end up with, 1 times, when x is 1, I have 2, plus when x is 2, I, oh my gosh, what is happening? That was weird. My pen doesn't really do that usually. When x is 2, I have 2 minus 1 squared plus that, so that's 3. Then I have, when x is 3, I have 2 squared, which is 4 plus 2, so 6. And when x is 4, I have 9, I have 11. And so this gives us, with the right endpoints, 22 is my approximation. All right, maybe I'll come back at the end of this and do the trapezoid rule, just so you can see that for the interested. Use the fundamental theorem, the second fundamental theorem, to find f prime of x. Fascinating. Why it wants me to use the second? I don't know. This should really just be cube root of x minus 4 is f prime, right? Taking that derivative. Yeah, great. So I'm going to go back and do the other, I just clicked my tongue, sorry, 20 with the trapezoid rule. Yeah, I suppose I should just say, I'm thinking, why do they say second? This is really the first fundamental theorem of calculus, unless they have a different 1 and 2 that they're talking about, for our book at least. All right, where you do the negative from the constant to x, that was the first part. The second part was about the definite integral with the endpoints being constants. All right, but anyway, let's go back up real fast. Actually, let's sorry for that noise cut. I was running into some technical difficulties here. Excuse me. So the trapezoid rule says this. I could do this, where, excuse me, the area could be calculated as the first, the last, plus 2 times the sum of the middles, where the widths are a half. What is he talking about here? Let's think about what this would really look like. I'm just going to give a little picture here, and maybe I'll zoom in then. So we look something like this. I'm just going to put it like so. Let's zoom in on this picture. If I wanted to, I'll do it in red. Cut this up into, let's say, 4 parts, or however many number. Trapezoid rule is just saying, well, we've done things with rectangles that were this size, rectangles that were this size. We've done things with midpoints, rectangles that were this size. What the trapezoid does is a little bit different. It just says, well, why don't we just ignore the rectangles for a second and just make these straight lines here connecting these endpoints? And I want to say Isaac Newton is the one who did this. So wouldn't that be nice? Now, what would be the area of this thing? So check this out. I'm just going to do this as if we had for this picture. Pretend for a second you had these left endpoints. So this height right here for this little rectangle, which would be the first, so that would be like f of 0. And then this little triangle here on the top would really be f of 1 minus f of 0 over 2. And then this next thing, if we did it in blue, this next rectangle right here would be, well, this bottom rectangle would be f of 1, so that's 1, 2, 3, and 4. F of 1 times 1, right? So our width here is 1, so we're sort of doing like with 1/2. And that rectangle, or this triangle right here would be 2 minus 1, right? So that's 1 is the width. It's going to be that the height is going to be f of 2 minus f of 1 over 2. Then we're going to do this likewise, f of 2 plus f of 3 minus f of 2 over 2, etc., etc., etc. So what we're going to see here is when I do all this, I'm going to end up then, dot, 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 we're going to get f of, well, I guess we don't really need dot, dot, dot. We'll just do the next one. F of 3 is going to be this rectangle, right, times 1. And then it's going to be the triangle up top would be f of 4 minus f of 3 all over 2. So if I go through and see, well, what do I really have here? I've got f of 0 minus f of 0. So that's just going to be the f of 0 over 2 plus I have f of 1 plus f of 1, and then this f of 1 right there. This is a positive f of 1 over 2 and a negative, so those will cancel, so we get plus f of 1. And likewise, we get plus f of 2 plus f of 3 plus f of 4 divided by 2 if I follow that out. And so what I'd be seeing here is, oh, these total values here, if I pulled out 1/2, it'd be 1/2 f of 0 plus 2, well, I guess plus f of 4 if we want to do the first and the last, plus 2 times f of 1 plus f of 2 plus f of 3. And so that's where I get that formula from. It's really just a process and some things cancel when I'm trying to think of another way of getting an approximation. Anyway, you don't need to know that for the test. I just thought it was interesting. There you go. Bob's your uncle. Although, wait a minute, I didn't even finish the problem, so I was just explaining what this thing is looking for. Actually doing the problem is not so bad. All we would need to say is, well, our width, let's do the problem here. If you know where it's coming from, you're just using the formula. So the formula would just say, do this. Let me do a nice big eraser. And plug in those values of what we're looking for. So we do the width was 1 divided by 2. When I plug in the 0 for this, I'd have 3. I plug in the last, that's when I plug in the 4 here. That would be an 11 plus 2 times the sum in the middle. So I'm going to plug in the other points along the way. Plug in a 1 for x, plug in a 2 for x, and plug in a 3 for x. So this gives me 1/2 times, that's 14. Well, I guess in here we have whatever, 14 plus 22. So that would be 36, that would be 18. There you go, using the trapezoid rule. And now Bob is your uncle.